Hello everyone, my name is Abhishek and welcome back to my channel. So today we'll be taking a look at some of the toughest Kubernetes interview questions, and just to let you know that all of these questions are not from my interview experiences, but I've taken help from GitHub sources. I've used some Medium blogs, and I've also put together my experience where either I'm interviewing someone or I was being interviewed. So I've put that questions as well. So watch the video completely and just don't look at the questions, but also look at the scenarios that I'm asking or the scenarios that I'm going to tell in this video, because they are more than important than the questions. Okay, so without wasting any time, let's quickly jump onto the video. And the first question that I have today is, what are some of the challenges that you have with respect to Prometheus or in general with the monitoring? So this question will ideally start from the monitoring point of view. Like, people will ask what are the tools that you're using for monitoring your Kubernetes cluster, and let's say you answer your question as Prometheus, because Prometheus is one of the most widely used in the Kubernetes space, right? So what are the issues that you faced with Kubernetes? So I always feel the toughest questions are the questions where you will be asked about your practical challenges with specific implementations, right? Because if you have to implement Prometheus, or if you want to use Prometheus as a data source and collect the information, that's not the toughest part. You have very good documentation provided by Prometheus. You have a lot of videos on the YouTube. But how an interviewer can evaluate you is by identifying the practical or real-time scenarios that you have faced with specific implementation, and how did you answer or how did you solve those practical scenarios, right? So one of the most frequently asked question, or if an interviewer has to understand your ability on the monitoring part of Kubernetes, so Prometheus challenges is one of the most frequently asked question. And I have put together some of the things here, but the most important thing is the Prometheus HA support. Like, Prometheus does not, it provides high availability solution, but that's not a very good solution. So I have also provided the alternative that the community has, which is Thanos. So Thanos is a cloud native computing foundation. I think it's an adopted, or at this point of time it might be incubation stage, but it's a cloud native computing foundation application, and you can use Thanos today, which effectively solves the Prometheus high availability problem. Like, let's say you just have one data source, one Prometheus data source configured for your Kubernetes cluster. Now, what if this Prometheus data source goes down for some reasons? So what will your answer be? You will be enabling high availability. So what are the challenges that you faced with high availability? So the problem is, you don't use Prometheus as a standalone tool, right? You integrate Prometheus with a visualization tool like Grafana, because Grafana provides you the Prometheus dashboards or your entire cluster dashboards. So now, uh, if you enable high availability with your Prometheus, to Grafana pick up the information from your Prometheus data source, it's not easy. So you have to enable a load balancer for your Prometheus applications, and you have to enable sticky sessions, because all the information has to go to only single data source from which your Grafana can collect the information. All this is a very complicated process. To avoid this, you have a very effective solution, which is Thanos. However, Thanos is a maturing tool or application, whatever you want to say, but it's a very good tool that you can watch out for, and I'm sure Thanos will stand as a solution in the future, which addresses the Prometheus HA support or the Prometheus HA problems. Now, moving on to the next question. How do you handle your Kubernetes cluster security? So there are two very important things with Kubernetes that from the security point of view. How do you handle your Kubernetes secrets, and how do you handle your Kubernetes cluster security? So handling secrets we have discussed in the previous videos, but now coming to the Kubernetes cluster security, which is very, very, very important, because as we move our workloads, or as we move our microservices completely onto Kubernetes, now how do you handle this cluster security, right? Because it's not that you just migrate all your applications onto cloud or onto Kubernetes and you say that okay, the migration is done. The important point comes when you are successfully able to secure your application after your Kubernetes migration, because on the on-premises side, uh, like the developers or the organizations have been hosting their applications on-premises over years now, right? Before the cloud migration, or before the evolution of Kubernetes, everything was managed on premises, and people were able to identify very good solutions on premises. But now, after moving to cloud or Kubernetes, the thing is different. Like over past 5 years or 10 years, people have been using Kubernetes or cloud effectively. But how did you effectively monitor your cluster security and your cloud security is one of the important questions. Now, to answer this is not a single point answer, right? You cannot just say that, okay, I used AWS cluster security, or you cannot just say that I use some Kubernetes security tools. That's not a standalone answer. So you have to provide step-by-step answers. You have to say that we have done a lot of things to improve our Kubernetes cluster security. We have secured the secrets. We have secured the pod communication using ingress rules. You can also talk about your network policies for your pod, and the most important thing, you have to say that we have enabled role based access control for the entire Kubernetes cluster, which defines which user has what amount of access on the Kubernetes cluster. And then for multiple people or the multiple projects using the same Kubernetes cluster, we have used namespaces to enable multi-tenancy support. And admission controllers are one of the important things, because you can do validating and mutating webhooks with your admission controllers, where you talk about these things, and you also say that we have front faced our Kubernetes cluster with an API gateway to whitelist the traffic that is coming into the cluster. And finally, you have to turn on the audit logging for your Kubernetes clusters. So these are some of the things. I'm not saying these are all of the things that you can do. If you personally ask me, I can add 5 or 10 points more, but to keep the content very restricted to the video, I'm just putting this 5 points here. But if any of you know more points, or you want to tell our subscribers about the security patterns that you're following for your Kubernetes cluster, which you feel are very good, please do comment on the comment section, so that others will be benefited from this. Now, after this, how two different containers running in a single pod, which has the same IP address, communicate to each other. Now, so the part one for this question is how do two containers inside a pod communicate with each other? So all of us know the answer. You can simply say that if the two containers are running in the same pod, they can access or they can communicate with each other using localhost, right? So if you use the localhost, because they are in the same pod, they can connect with the localhost call and the port number. But this is a very easy question. Now the question the interviewer asks after this, like if you're facing a very tough or very good level of Kubernetes interview, the next question that comes here is how does this happen internally, right? Because they have the same IP address, they are communicating with each other. But how does Kubernetes handle this scenario internally? So the thing that you have to talk here is about the POS containers, right? So Kubernetes makes use of the POS containers for sharing the networking with the containers in the same pod. So this is a very interesting topic, and I would highly recommend everybody to go and read about the POS containers. I have provided some information here, but this is very a minimum for you to answer the question in an interview. But if you want to understand in depth about how the POS containers works, and what are the advantages, how Kubernetes leverage the POS containers for the communication between containers in the same pod, is a very interesting topic, and I would highly recommend you all to go through this. Now, the next question that I have here is, what is service mesh and why do we need it? Some people might feel that this is a very easy question. Like service mesh is used for east-west traffic within the cluster, and you can say that for a service to communicate with other service securely, you can use service mesh. That's the purpose of using service mesh. Or you can also say that for enabling mutual TLS, and service mesh provides you some capabilities like load balancing, observability, traceability, RBAC, authentication and authorization. But how you answer this question is very important, because if you know about service mesh, say that you know about service mesh. If you don't know about service mesh, just say that in our cluster setup we did not have to use service mesh, because the service to service communication can be used. You don't have to use mutual TLS. We can do a very simple secure, very basic security between service to service communication. So if you know about service mesh, then go into the details of it. But if you don't know, better don't go into it, because you'll be asked about the sidecar injection, you'll be asked about the envoy proxy, and the hell lot of things about the disadvantages of service mesh. So answer this question very carefully. If you don't know, just say that I just know the theory of service mesh, how does it work, but I have not practically implemented it. So then the next question is, what is init containers and why do we need it? So some people don't know the concept of init containers, and some people who have worked on the Kubernetes application or the development side of it, they might know why init containers are used. So in a nutshell, init containers are the containers, that you should run to complete a specific activity before the startup of your actual container. So let's say I am using Argo CD as my main container. Like let's say I'm an Argo CD developer, and I want to mount a specific volume even before my application controller of Argo CD is running. So in that cases, you can use an init container, and you just don't have to use a single init container. You can use multiple init containers as well. And I have pasted a Medium article which talks about this init containers as well, how they are used and what are the steps that you have to be very careful while using init containers. But for the question point of view, you can simply say init containers are the containers that you have to run before the startup of actual containers for performing a specific activity, like for using a basic sleep, or for using mounting a specific volume before your actual container is starting inside a pod. These are some of the examples. The next question is, what is pod disruption budget? So again, this is a very important thing. Like if you're using Kubernetes in a real time, if you're using Kubernetes in production, like you have to have these kind of things. Like the pod disruption budget is one of the things that you should definitely have. Now, before going to pod disruption budget, you need to understand what is the difference between a voluntary and involuntary disruption, right? So here I have provided the differences between voluntary and involuntary disruption. So if you don't know about this, just pause this video at this point of time and read about the voluntary and involuntary disruption, because now I'm going to talk about pod disruption budget as an interview question. And just to answer it, pod disruption budget handles voluntary disruptions. Like it cannot handle the involuntary disruptions, like for example, your cluster going down for some network related issue, or your virtualization related issues, or some other things. But for activities like voluntary disruptions, you can rely on the pod disruption budgets. And what this pod disruption budget does is, you can specify a specific number of replicas that an application can tolerate having relative to how many it is intended to have. So for example, the replicas count that you have provided is 5, and in your pod disruption budget, you say that at any given point of time I should have 4 pods. So what happens is, for some voluntary disruption, Kubernetes talks to the eviction API, and it will only allow the voluntary disruption of 1 because your pod disruption budget is 4. So this is about a basic example. And yeah, just take a pause here, and if you don't know about the pod disruption budget, just go through the theory part of it. Now, the next question is, what is a custom controller? Did you build one, and how did you build? So the reason why I did not put any theory here is because this is a very lengthy topic, and I couldn't basically, I started writing, but I couldn't finish it in a single slide. So I thought I'll just explain it here. And maybe if you want this as a different topic, we can even take this as a different video, because custom controllers or custom resource definitions is a very lengthy topic in Kubernetes. So to start with, how do you answer this question is, custom controllers are basically used to handle the reconciliation of custom resource definitions. Now I'll simplify this. This is a definition, but if I have to simplify this one, so Kubernetes does not handle each and every scenario that you want, right? So a basic example is ingress controller, right? Ingress controller is a custom Kubernetes controller. It does not come by default on your Kubernetes cluster. Okay, so what happens with an ingress controller is, ingress controller or any other controllers, let's say Nginx or Traffic or Ambassador or F5. So what they do is, either they watch for the native Kubernetes resource like ingress, or they also define their own custom resources. Like for example, if you're taking about service mesh, right? So service mesh would watch for custom resources like virtual service or ingress gateway. So what are these things? They are the custom resources. So how do you define these custom resources? You actually define a custom resource definition, and you submit it to your Kubernetes cluster. Once you submit them to your Kubernetes cluster, now you will be able to deploy your custom resources, because Kubernetes can identify, okay, whenever you are deploying a virtual virtual service, Kubernetes says that, okay, there is a custom resource definition for virtual service, and now I can understand what you have submitted to my Kubernetes API. Now, once you do this, like you just deployed a virtual service, but somebody has to handle this virtual service, right? Somebody has to handle your virtual service. Somebody has to handle your destination rules or your ingress gateway, which your Istio has, or I mean, which your admin or your developer has provided. So who handles this one? This is handled by a custom Kubernetes controller, in this case, a service mesh or an Istio controller. So this is about your Kubernetes custom controller. And you can give the same example that I've given at this point. Like you can take the example of Istio. And if you have written a Kubernetes custom Kubernetes controller, you can answer that you have written. If you have not written, you can simply say that I did not get a chance or I did not get a requirement to, write a custom Kubernetes controller. So this is about this specific section. And then what is sidecar container and when to use it? So if you are already aware of Istio, sidecar containers or sidecar injection takes place when I mean, this is just an example. Sidecar containers is a different topic, but I'm taking Istio as an example. So I'm saying when you are deploying Istio, what basically happens is Kubernetes makes use of the admission controllers. In this case, basically a mutating webhook, and it creates a new container aside your proper Istio or aside your main container, right? So in the same pod, aside your main container, Istio using the mutating webhook and the Kubernetes API, it deploys a sidecar container. And what is the responsibility of this sidecar container? The sidecar container in terms of Istio, it basically handles your traffic routing, like what are your destination rules, and who can access this specific application and all these things. So this is about sidecar containers using Istio as an example. But if you want the generic definition, whenever you want to extend the functionality of your existing single container pod without touching the existing one, right? So let's say that you have a container A and you have to handle this container A without actually touching container A, which happens similarly with Istio, right? Whenever you are deploying Istio service mesh onto your Kubernetes cluster, Istio does not even touch your main containers. What happens? It does not touch your application, but they deploy some other traffic rules which using envoy proxy, and they use the concept of Kubernetes mutating webhook admission controllers, and they deploy a sidecar container just besides your actual container. So once you deploy Istio, you can see that your pod will have two containers. I mean, initially if you have one container, after deploying Istio, you will have two different containers. So this is the concept of sidecar containers. Now, once you answer this interview, might also ask you what are the other different types of containers that are available. Like, we already discussed about init containers. Now we discussed about sidecar containers. Are there any other containers? Yes, there are. So that is again your homework. So whoever is watching this video, search for different types of containers like init containers, sidecar containers. Then you have ambassador containers, and then there is one more, which I'm just leaving it for you to explore. Finally, we have pod security policy. So pod security policy, the reason why I've put it at the last, because this is one of the very important ones, but the reason why I've put it at the end is some people might not be aware of this concept because it went into beta in Kubernetes 1.22 and it is just GA in Kubernetes 1.25, right? Or 1.25. So many people might not be aware of this concept, but because now we already have Kubernetes 1.25 and people will start using it. We have to use it because we have to use the latest version of Kubernetes anyways. So you will understand the significance of pod security policy, and this is again something that I want you to explore by yourself. Kubernetes has a wonderful documentation for pod security policy, and I can leave this topic as your homework or something. Like I already explained you about different things, so just as because you watched the entire video, just take this as your homework, or just take this as like couple of minutes spent on pod security policy. It's not at all a complicated topic. You hardly will spend 5 or 10 minutes to read about Kubernetes pod security policy, which is available in Kubernetes 1.25 documentation. And yeah, personally, I'll feel very happy if somebody spends some time after watching my video. So I'll leave this question for you to read, answer, and then comment in the video. Comment down on the video if you have spent some time to read about pod security policy or not. So that's all I have for today, and I hope you found this video informative. Don't forget to like this video, comment on the video about your thoughts and what did you feel. Did you like it? Did you not like it? And don't forget to share this. And if you have not subscribed to my channel, please do subscribe to my channel. Only 40% of our viewers have actually subscribed to my channel. So please consider subscribing, and if you have any feedback for me, also share that in the comment section. I'll see you in the next video. Thanks. Take care.